সাইক্লোন ভোলার কথা প্রথমে দেখা 12 এবং 13 নভেম্বর 1970 না, ওই যে ইউআর এর গ্লোবাল কনফারেন্স গুলো হচ্ছে না, সেশন গুলো হচ্ছে, তো আর্লি মাল্টি হাজার নিয়ে প্রথমে ইয়ে হচ্ছে।
My apologies. I was muted. So thank you for the video, Erica. So here we are. In the interest of time, I will not anticipate on the content of the presentations, of course. So let me introduce our speakers who kindly accepted to contribute, share their experience and knowledge today with all of us. So colleagues and friends, thank you. I'm still not sure if our first planned speaker is connected. He is not a meteorologist, but how could we consider holding a session without the United Nations Office for Disaster Risk Reduction, one of our key stakeholders and partners. So Raul Salazar, the chief of the UNDR Regional Office for the Americas, based in Panama, will hopefully be with us in a few seconds. Raul has been working in this Americas office for almost 10 years now, and previously worked in Peru's UNDP office from 1997 to 2010. He was a member of the United Nations Disaster Assessment and Coordination Teams that we all know as UNDAC since 2003. And as such, he participated in a number of coordination missions, including the one in Jamaica after Tropical Cyclone Ivan in 2004. So very early schedule for Raul. Hope his connection issues are sorted. Next will be kind of Raul's regional counterparts are my colleague Rodney Martinez, who is the WMO representative for North and Central America and the Caribbean. Rodney is based in Costa Rica. He has a very strong background in research in the field of oceanography, marine sciences, as well as climate risk management. Prior to joining WMO, Rodney worked for CFEN, the International Research Center on El Nino, of which he was the director from 2015 to 2019. Rodney, thank you also for joining us. Still from the Caribbean, we'll have next Mr. John Tibbetts, the Director General of the Cayman Islands National Weather Service. John has developed a very rich experience, starting his career as a certified operational meteorologist. So that's two of us, John, here today. And he took further opportunities of professional training with Mississippi State University, the Environmental Prediction Center Tropical Desk, and the National Hurricane Center in Miami, Florida. So John is a strong supporter of WMO activities. Thank you also for joining us today. We'll then move to the South Pacific, and it is our pleasure to have Mr. Alan Rarai, the Acting Director of the Vanuatu Meteorology and Geohazards Department, degrees in Physical Geography and Public Administration from the South Pacific University, as well as a Master of Science from the University of Auckland. Alan has been serving the government of the Republic of Vanuatu for more than 20 years actually, of which more than 10 were dedicated to providing and managing weather and climate services. And last but not least comes my dear friend, Mr. Musa Mustafa, Deputy Director General of the National Institute of Meteorology in Maputo, Mozambique. His background is physics meteorology and agrometeorology, for which he holds a Master of Science degree from the University of Harare, Zimbabwe. Throughout his 25-year-long career, he has worked on disaster risk reduction issues and led the development and implementation of various programs related to early warning systems, including a position with UNDP as the national coordinator of a tsunami warning pilot project in the years 2010-2011. A very rich experience again. Thank you also, Musa, for joining us today. So I will now hand over to Rodney, and we'll check if Raul is properly connected at the end of your presentation, Rodney. Rodney, the floor is yours.
Thanks very much, Cyril. Just checking if my sound is good. Just a confirmation.
We can hear you.
Okay, thank you. Thank you very much for this opportunity. I would like to make a presentation to try to use the recent experience, the Atlantic hurricane season, just to reflect on what is going on in terms of the multi-hazard early warning systems and how we can move forward for continuous progress on the benefit of the most vulnerable communities. The next, please. And next slide, please.
Sorry, Rodney, my screen seems to be frozen.
Let me try from here if I can have the control. Try to do it here. Okay. Okay. Let me confirm if you have the presentation.
Yes, we have it, Rodney. Thank you.
Okay.
That's great.
Okay. Okay. I'm joining very proud into the 40th anniversary of our WMO Tropical Cyclone program, and I think that this session is honoring that because we need to continue reflecting on what is going on and remember what WMO has been doing in this contribution with all the other partners from the UN family and governments, NGOs, etc. One of them is this publication, which is really very useful and very pragmatic to assist the member countries in the implementation of multi-hazard early warning systems. This checklist, which is the result of a long process of consultation, lessons learned, experiences, and update the original document produces as an outcome the third International Conference on Early Warning and Concept to Action. This is the kind of assistance that we need to provide and to follow up with our members in order to move forward. And from the conceptual point of view, the multi-hazard early warning system approach implies a lot of challenges and needs a continued effort to keep supporting in the implementation, to provide guidance, and of course, exchange the experience. Since we had a lot of facts to analyze in this hurricane season, it's a good opportunity to reflect on how this schematic of multi-hazard early warning system is taking place and what are the gaps we feel. When we talk about pillars, we know the concept, we know very well all the pillars of the early warning system, but it's very hard to implement them in the reality. There are practical issues, there are governance issues, there are difficulties, but of course we have good news in terms of what has been achieved, what has been, and the progress that we have in several of these pillars. But if we are not integrating the pillar as a whole, the whole early warning system, the multi-hazard early warning approaches not taking place are not being so effective as we hope. Another important concept promoted by WMO is the multi-hazard impact-based forecast. And that implies a new approach for warning services, try to connect with the decision makers, trying to get a more effective response from all the stakeholders and the users. And this is something that we are promoting strongly around the world, and in Central America and the Caribbean region is no exception. So we are trying to move forward in this direction. But of course, we have challenges here. So when we talk about the hurricane season, we try to find this. The key facts of this hurricane season, the most active Atlantic hurricane season on record, the 7th costliest on record, the 5th consecutive above average Atlantic hurricane season from 2016, and the first extremely active season since 2017, 31 subtropical depressions and tropical depressions, 39 storms, 13 developed into hurricanes, 6 further intensified into major hurricanes, with 1 hurricane Yotas attaining in Category 4. And it was the second season to use the good level storm naming system. The first was in 2005. So,
Rodney,
yep.
If you could speak a bit closer to the microphone, maybe it could help us.
Okay, sorry.
Thank you.
Okay. Oh, okay. My screen is frozen. Okay. This is a very it's a picture which tries to reflect what happens with ETA and IOTA, especially in Central America and North and South America, in terms of what happens, in terms of the impacts, and a summary, a preliminary vision, a summary of impacts, an impact overview. As you see, there is a characteristic in this hurricane season is a severe impact in Central America because of consecutive systems striking the continent, and of course, that involves also countries from South America, like Colombia and Venezuela, especially Colombia with the San Andres and Providencia Islands, and then practically all Central America. And this is a summary of the response. Of course, it's a document from the European Commission, but provides a very good overview of what happened. So I would like to share some reflections in this regard. And the multi-hazard early warning systems, based on that way we could see in the region. And this reinforced the idea of the multi-hazard early warning system needs to be evaluated regularly and corrective actions implemented. It's something that we need to document. It's something that we need to really monitor in terms of performance. And these adverse events are the opportunity to do that. We really need to have performance objective indicators for multi-hazard early warning system. They need to be established and further monitored. Very simple, but very pragmatic, in order to show us how, what should be improved in a very objective way. And we need, and the experience is that we need that this multi-hazard early warning system should operate under a specific national and local legal framework. They need the support of a legal framework to operate and to be sustained. And sustainability is a key word. And it implies that we need to break a paradigm, not continuing thinking in the sustainability of external resources of cooperation to maintain the multi-hazard ecosystem because they are vital, they are key for prevention, for saving lives. So this should be a priority for the states, for the governments. And of course, the external cooperation is needed to trigger further processes in order to motivate the governments invest in the sustainability of the multi-hazard ecosystem. This is the real, this is the most effective way to ensure sustainability. When the government owns these multi-hazard ecosystems and sustain them in the time with more investments. Credibility and awareness raising is important. High technical and scientific standards are the key, but we need also clear protocol for spokespersons. And we need to try to mitigate the political manipulation of these technical systems which are supposed to prevent and to save lives. So these protocols for spokespersons should be really strict and must be followed. And a coherent, sustained, and innovative communication strategy should take place. We are moving in a different environment in terms of communications. How to fight with misinformation and fake news. We have an extraordinary flux of reliable information thanks to all the organizations that WMO has been promoted around the world, and the Caribbean region is no exception. We have the Hurricane Committee working there with a strong coordination with the services. We have a lot of technology, scientific advances there. And so the flux of information, the reliable and authoritative information was there. But we were fighting with the fake news, with the misinformation, the manipulation of some media. So that is important to take in account because it's there. It's a problem that we have to manage. We need to mobilize citizens, especially young volunteers, to strengthen local dissemination networks because we are not covering the last mile, the remote places, the rural sectors, the indigenous communities. We are not getting there. And we need more extensions to our traditional networks. We need extensions with new interfaces in these remote places, the last one, that is critical. And that implies that we need to build on strategic alliances, including the private sector. The private sector is a beneficiary of multi-hazard organizations that need to be involved and need to invest because they receive the benefit of these systems. So it's important to involve them. In terms of governance and institutional coordination, and these are the real big challenges here in the region, and maybe in other regions also, is that the meteorological and disaster risk reduction institutions must work together. We cannot moving forward in silos, producing parallel information, which is not the way. The decision-making process for planning and response must be based in co-designed products to identify the most vulnerable areas, to estimate the potential impacts, and prioritize the use of available resources for a more effective response and preparedness planning. The response must be multidimensional and is entirely dependent of a consolidated institutional framework and strong governance for disaster risk reduction. We need to work together in this field because we can have the best information, but if we cannot really make progress in the interface at the governance level and the coordination level, this rich information that we have, this valuable scientific input that we have, will not be effective. Thank you very much.
Thank you very much, Rodney, for this sound presentation. A number of considerations that will probably be discussed with the audience later. Some of them are actually key as you outlined. So without waiting further, I would like to move to John for your presentation. John, the floor is yours, and we'll come back with Raul if he's able to connect later. John, the floor is yours.
All right. Good morning from the Cayman Islands. I know that's a bit strange, but we're far over to the west. This here's my presentation on the past season. Next slide, please. Erica. Hello.
Yes, sorry, John. So it seems that my screen is not able to move forward in advance. So I don't know if you can maybe share your
I
screen.
can. You need to unshare yours. I'll share mine.
Okay.
Oh. Okay. Everybody can see mine?
Yes, thank you.
Okay. Oh, terrific. Give me a second. All right. Well, hopefully this will work. Here's the layout of the presentation that I've got prepared. Just a look back at the 2020 hurricane season in terms of what we were looking at for a forecast. Brief mention about the climate for the last 30 years. We'll talk about some impacts and lessons learned for the Cayman Islands. We'll talk about collaboration with the DRR community, and we'll talk to the Cayman Islands transition into an impact type forecasting. Whoops. Okay. So first, we will look at the hurricane season. As we went into the 2020 hurricane season, we looked in the month of April, and we looked at the forecast for the season. And the first thing was an analysis of the factors driving the season. And it was noted that we had currently had a warm, neutral El Nino La Nina cycle, and it was expected to transition to a cool neutral or weak La Nina by the summer or fall. Additionally, we had above normal sea surface temperatures. And so the forecast for it was an above normal activity season with 16 named storms, 8 hurricanes, and 4 major hurricanes. The forecast that came out of NOAA was slightly above this level. So as we went into the season, we note on the right-hand side there first that a normal Atlantic-based hurricane season is about 12 named storms, 6 hurricanes, and 3 major hurricanes. And instead, we ended up with 30 named storms, 13 hurricanes, and 6 major hurricanes. So in most instances there, you're over double the regular season, what you would normally get. Just to say in brief that in terms of climate change, the indications from research in climate change does not really support necessarily an increase in the numbers, but the indication is more along the lines of more major storms. Okay. In terms of the impacts on the Cayman Islands, I divided it into, we were impacted by 6 systems for the year, 3 minor systems, Tropical Storm Marco, Tropical Storm Nana, and Tropical Storm Zeta. And you can see the impacts here and how close they came to us. Most of them are basically rain events. But when I separated them out, the minor storms did not result in the Cayman Islands issuing a tropical storm warning, for example. The 3 major storms that we had were Tropical Storm Laura, Tropical Storm Delta, and Hurricane Ada. That probably should be listed as Tropical Storm Ada because I'm quoting the status of the storm as it passed the Cayman Islands. And you can see the impact here for each one of these in terms of seas and winds and what have you. Note that these 3 particular storms all required the issuing of tropical storm warnings for the Cayman Islands. And some of them were not as straightforward as one would think. Some of them gave us some difficulties. So this is some of the images of some of the impacts in the Cayman Islands. This is downtown or Georgetown capital, and the waves came ashore and were washing into the streets where we normally drive our cars. And this picture is extremely interesting for me because it actually takes us back to what looks like what used to be Hurricane Ivan when it impacted the Cayman Islands. This is a tropical storm Eta going through the Cayman area. And this area here, the damage is enhanced by the passage of an F0 tornado, which we were able to track and look at using our weather radar. This is another example of some of our light poles that we believe were downed in straight line winds, like a gust front, as it were. After each one of the passage of each one of the storms, we normally have a debriefing and have a discussion about lessons learned. The major areas here that we had lessons learned was that in terms of the weather service, the staffing numbers needs improving. I think we're at this conference, we're actually looking more at DRR, but please understand that a national weather service has a lot of other customers as well that we need to have staff to run that services for those individuals. Our website was not adequate, and so we're looking at upgrading our website. And ultimately, after when we got near the end of the season, we realized that all of our customers were better served using impact forecasting and warning. In terms of collaboration with the DRR community, the Cayman Islands National Weather Service has always maintained an excellent relationship with the various components of the DRR community. And the DRR community is headed up by what we call Hazards Management Cayman Islands. And the former director of the National Weather Service was a significant supporter of the creation of Hazards Management Cayman Islands after Hurricane Ivan. It should be pointed out that the staff and the organization, we're not outsiders, but we're part of the whole community. We don't live in a bubble. We have our own work to do as well. Joint radio shows with the disaster management is the norm. And our transition to impact forecasting is actually driven by a disaster manager as well as a National Weather Service forecaster. The drive to get into more disaster management forecasting was driven by a Cruise Caribbean workshop that was held earlier in the year, in which some of our forecasters and some of our local disaster managers were involved in it. And they came out with some challenges. And for us, one of the big things is data and forecasting capability. And again, you notice on there and highlighted in red, the staffing issues is always a problem. However, there are some opportunities to build partnerships with the private sector and to learn how to better word or forecast to satisfy our customers. In terms of prioritizing areas, we looked at tailoring our messages in a better way to satisfy our customers, proper training of our forecasters, and as well as to create a strategic plan that would allow us to get extra funds to support impact type forecasting. So we'll turn our attention a little bit now to the transition into the impact forecasting. Going into the year, the National Weather Service would issue what we call weather notifications. And what you're looking at is a sample of the product, giving us latitude and longitude and basic information on the storm. And everything was in one big slide. And along came Tropical Storm Eta, and as I said, Tropical Storm Eta. I call it Tropical Storm because when it hit the Cayman Islands, it was a tropical storm. And this is the track of Ada. It looks like a kid went crazy with a squeegee board and a pencil. It's a real crazy pattern. And ultimately it passed 33 miles north of Grand Cayman on November the 7th. This is one storm that we had numerous problems with. In fact, not only us, but the Hurricane Center. The Hurricane Center had problems exactly locating where the center of Ada was when it weakened to tropical depression over western Honduras and east of Belize. Additionally, after it had weakened to a tropical depression and turned northeast towards the Cayman Islands, there were two center relocations that moved the center further towards the Cayman Islands in both cases. And so we transitioned when we got to Ada into more of an impact type forecasting. So we would put out our normal weather notifications as you see here with the standard information, but we would also then turn out to releasing specific weather notifications, flood information, and marine advisories and gale force winds that we were expecting from Ada. We do have other weather notifications, as it were, in terms of impact type forecasting that we will be building on in the future. Once we came out of that, we noticed that our customers were very receptive to the new impact forecasting and warnings. However, it should be pointed out that your impact forecasting can be negatively impacted by model limitations. And where that is, why we say that is because the same models that we use to track the storms is usually the same models that we use to predict or produce our forecasts. And sometimes the models are slow in adjusting to new forecast tracks of storms, as it were. One of the things that was evident for us is that our customers were better prepared whenever we had tropical storm or hurricane type warnings that had to be issued with less than 36 hours notice. And sometimes, unfortunately, this happened. And with us, Tropical Storm Laura in particular, this was what happened. But because they were already advised with some of the things that we were doing, they were better prepared. Okay, to properly run impact forecasting at the National Weather Services, we need to have some tools. And so these are some of the tools the Cayman Islands National Weather Service is looking to get. We do have what we call a wave modeling computer that can give us fine detailed information on waves to help our marine warnings. We're getting some LiDAR bathymetry data to enhance that, as well as our storm surge products. And we're looking for a fine gridded precipitation model to assist with our flood warnings. We also have a network of automatic weather stations and weather buoys that is we're pushing, as well as a central home for the National Weather Service to operate from. We think that we are moving in the right direction, and we've got a significant amount of government support to ensure that funds are available to pay for the equipment and the staffing that we need. It's just that the staffing is coming at a slower rate than we'd like, as it were. So basically, that's my presentation on for the impact forecasting and what has gone on in 2020. And I guess once we get to the section about questions, you can, I'd be willing to answer any questions you have.
Thank you very much, John, for this very comprehensive presentation. I'm no doubt that this will trigger some questions as you went into a significant level of detail and information. Probably people will be interested in knowing even more.
I
Thank you
apologize
so
for
much.
how fast it had to be said.
No, and that's very appreciated that you could put this together. And I bet we'll have follow-up questions on this. Thank you very much. Let me have a quick look. Maybe we are going to now change from the Atlantic and the Caribbean to the South Pacific with Alan, whose presentation is appearing on my screen. So this is from you, Erica, and it seems to work. So Alan, the floor is yours.
Okay, thank you, Cyril, and thank you, everyone. It's good night from Vanuatu. I will do a presentation on the trend for the last 30 years, more than 30 years, and a case study on the Tropical Cyclone Harold, brief on Tropical Cyclone Harold, and the warning response from the community response, and what the communities are using to respond to warnings from the Met Service. So that's probably what I'll be presenting on today. The next screen. This is the area of responsibility that Vanuatu Met Service is responsible to issue warnings and information advisories on tropical cyclones and systems that moved into the areas. So we're having from 10 degrees south, just a small area, to 20 degrees south, and 160 degrees east to 175 degrees east. So it seems like our area is covering us New Caledonia as well. But Vanuatu is sort of from north to south, so that's a long line of islands. So next screen. Okay, for the number of tropical cyclones in Vanuatu during the last 39 years, significantly there's a downward trend in the total number of the tropical cyclones since 1981-82 season. So this appears on the screen. So this it's consistent with the overall downward trend in the DC for the Southwest Pacific region. So that's the statistical analysis of the last 39 years. So the next screen. For the intensity, there's not much change in the intensity for the categories 3 to 5 TCs with pressures less than 970 hectopascal. So we are forecasting this analysis is based only on the cyclones that move inside the area which I mentioned earlier. It does not cover the whole Southwest Pacific, only the areas that is I've mentioned earlier. So the intensity is not that big change in the intensity of tropical cyclones with more than category 3. Next. This is a summary of warning services for the past cyclone season. I think category 5 cyclone TC Harold. We had on the left, that's the tracking, the track focus track map we are using. It's a product out of TC module. We have a brief in the middle. There's a brief outline of what happened during TC Harold, and then the warning products that we issued during TC Harold on the far right. There's some pictures down at the bottom, impact on the communities. So we issued a total of 34 warnings. The warning system is we have information, around gales, and then we have advisories, and then we have warnings. There's a dissemination tool that we use to push out the information to the public. Next slide. This is one of the tools that we use, the tracking. On the right is the tracking map that we use. The public use this to locate the position of the storm. And on the left is the focus track, the actual position and the focus track as a product of TC module. So this is what we used. I think the tropical cyclone tracking map is the most used in a tool by the local people and almost throughout the population of Vanuatu for tracking the tropical cyclone. That's the community response. This is part of the tropical cyclone tracking map. And this is what the communities will respond if information is issued from the forecasting center. For the blue alert, this is done, this information will be issued by NDMO, National Disaster Management Office, based on the information and the warnings issued from the weather service. So the blue alert is issued in preparation for the onset of gales within 48 hours. And then yellow alert and the red alert. Yes, I think that's all for my presentation. This is my first time to join the season, and this is all I have for now. If there's any question, I will be happy to answer. Thank you.
Thank you very much, Alan. Very appreciated as well. We could observe a very interesting information on the specificities of this South Pacific basin, especially regarding the trends that you showed that are aligned with the overall climate change research that was carried out on a global scale compared to this exceptional season in the this exceptional hurricane season in the Atlantic, which is record-breaking. But the overall trend, we have more confidence that the stability of the number of the frequency of events here. So thank you very much. Your information on the warning system implemented in Vanuatu is also interesting with an approach which is kind of anticipation based from the NDMO scheme. So we'll probably have comments or questions from the audience as well on this. Okay, thank you again. And from the South Pacific, let's move now to the Indian Ocean. And Musa will be presenting for the Institute of National Institute of Meteorology, Mozambique. Musa, the floor is yours.
Once again, thank you very much for providing this opportunity to share some information related to tropical cyclone. Yes, move to next slide. I think you know that Mozambique is a country prone to natural disasters. The main with floods, droughts, tropical cyclones, flash flood, and waterborne diseases. And the country is so big, And according to the last population census, we about 30 million people. And most of them are living in coastal area. So tropical storms and tropical cyclones are considered as low frequency events. For example, we are talking now about tropical cyclone IDAI that affected Beira City in Sofala province. The last time Sofala province was affected by tropical cyclone, it was in 2000. It was a tropical cyclone, Eline. And compared with the two tropical cyclones, we found that IDAI and Eline was category 4, but in terms of impact, it's very, very different if you compare this time. Next. Talking specifically on tropical cyclone IDAI, we know that March 2019, tropical cyclone IDAI affected the central region of Mozambique. It affected 4 provinces, but Sofala is the province with more impact. And from us, what makes tropical cyclone IDAI different is that if you see one of the picture with the track of the tropical cyclone, you see the erratical track. So the system formed almost the course, moved to the interior area towards Malawi, then it returned to Mozambique channel, and it intensifies and again returned to Mozambique. So this is a big challenge for all scientists because it's not common to see such kind of a track, the system of moving into land, again return to the ocean. So we need to study this kind of a system. In terms of impact, you can see from the pictures, we had the cut of the communication lines, power outage, road cut, damaged buildings, and other infrastructures. The system was so strong with winds, gust winds of about 230 kilometers per hour. And the country is still recovering from the impact of a tropical cyclone IDAI. Next. Well, when we're talking on collaborative with the disaster risk reduction community, how we are organized in Mozambique. We have 2 main agencies on early warning system. I'm talking about the National Meteorological Service and the Water Resource Management Organization. So we are dealing with the meteorological hazards, and the Water Resource Management deals with the floods. So we are part of the, years ago was approved the law where National Meteorological and Hydrological Service is part of a disaster management unit. During the rainfall season, we have a technical group that work in straight collaboration with the Disaster Management Institute. We provide the daily forecast, we collect rainfall data daily, and we send to the water authorities and to disaster management. And when there's a tropical cyclone, we have a group of technicians that are based on INGC, and they work 24 hours per day before, during, and after the tropical cyclone. So it means that we have a good collaboration with the disaster management community. So this involves the United Nations agencies, private sector, and other organizations. Next. Well, after tropical cyclone IDAI, the world was aware of what was happening in Mozambique, and the WMO Secretary General decided to send a team of experts to Mozambique in order to evaluate, to assess the infrastructure, the functioning of the early warning system, and our capability to respond all kind of disasters. So after the mission, they issued a report. So I picked it up, what I found important for our discussion. So there is a need to enhance the capacity of INAM in the following areas: observation systems, hazard risk assessment, detection, monitoring, analysis, forecast, and dissemination of warning. I think the monitoring, the detection, analysis, and the dissemination of warnings are more crucial, because what happened during tropical cyclone IDAI is that our meteorological station in Niberia was the first to be affected. It means that the day the tropical cyclone reached Niberia, we did not have data. With no data, so it is challenging. We needed to have resilient systems in order to continue our observation, in order to continue the monitoring of the system. So even from the other side, the water authorities, they need to invest in order to be able to provide good warnings for floods to our community. Next. Warning communication needs to be enhanced. The warning message needs to be used, oriented, and targeted to various audiences with a clear indication of a potential impact. For example, I saw my previous colleague from Vanuatu. He was presenting the early warning system that uses 3 colors. In the past, after tropical cyclone Eileen in 2000, we developed the tropical cyclone warning in the country. It is a color-based, and the disaster management, after 10 years, they also developed their early warning system, alert system based in colors. But at the moment, what's happening in the country is that the same color for the 2 institutions, the meaning is different. For example, when we say red alert for tropical cyclone, it means that the strong winds, 6 hours we expect to affect some areas. But for disaster management, the colors mean the level of response, the level of response that they provide. So the mission found that the color coding system used for communicating warning, used by INAM and water authorities, need to be harmonized and should be differentiated from the color coding system used by INGC for readiness levels of the institution involved in disaster risk management. So this is one of the challenges we have in the tropical cycle. So I saw from my previous presenter in terms of the threshold time. For example, in Mozambique, red color we use for girl with the 6 hours, but they say 24 hours. I think maybe in the future we need the intervention of a WMO to harmonize this kind of events. So in order to, for example, if my colleague come in Mozambique, if we find a red alert, you will think that we are talking about 24 hours, but locally we consider 6 hours. Next. Well, in terms of the impact-based forecast, this is a challenge. It's challenging for the country because we consider this as a new thing. I think Neri is hearing me, is involved in mobilization of the resources for Mozambique to implement the impact-based forecast. But under the pilot project for climate resilience, National Meteorological and Hydrological Service together with INGC and the agriculture sector implemented a pilot project on impact-based forecast for farmers and fishing communities in the few places. So what we did is to provide training of the local communities on the interpretation of meteorological information, production of signal bodies for use by local fishing communities, allocation of mobile phones to the communities to enable them to receive the warnings, and support with equipment to the community radio stations for dissemination of the warnings. So this is the first time we deal with impact-based forecast to the communities, and we know that the involvement of the community is very, very crucial, is very, very important, because we need a people-centered early warning system that rely on the direct participation of those most likely to be exposed to hazard. But I said it was a project, so the project ended in December 2019. And to expand to all the country, it's challenging because it needs resources. So another thing is that in Mozambique, as I said before, most of people, of communities are living near coastal line. And the use of a local language, we're not like other countries where you find 2 or 3 local languages. In this country, we have many, many local languages, and to deal with all communities is challenging for us. And we need a support for government, for international communities, even from WMO, in order we set up impact-based forecast for all countries. So this is the information I prepared to share with you in this segment. Thank you very much.
Apologies, I had to unmute again. Thank you very much, Musa, for this nice presentation and the comments that you could make a linking with the previous one, so we can see and identify those areas that belong to national frameworks for disaster risk management with different approaches that make sense and can be considered from a variety of perspectives. So that was very nice. Thank you. I believe we now have Raul Salazar from the UNDR Office for the Americas online.
Hello, good morning.
Oh, excellent, Raul. Good morning. And so without further comments, as we are moving on our presentations, I would be happy to give you the floor for your contribution in this, and we are kind of closing the loop as with we started with Rodney from the region as well. So Raul, the floor is yours.
Thank you. I'll share my screen with you. Please confirm if you can see it properly.
Right. It works.
Okay, can you see it?
Yeah, excellent.
Good, thank you. Well, first, my apologies for just joining you this morning. But what I wanted to present is a request that we have after a conversation with Ronnie regarding our work that we have been developing in the Caribbean jointly with ECLAC on the an approach that we are fostering in the region, actually globally, but we are developing some pilots in the region, which is trying to assess the systemic nature of risks. But basically, just to put the context of these efforts, is basically an effort that is anchored in the current situation that we see now in the Americas, and particularly in the impact that disasters are having in terms of the numbers, but also in terms of economic losses that the Americas and the Caribbean region is facing. This is a report that we have recently launched. We launched it during the International Day for Disaster Risk Reduction, that analyzes, for example, the disaster impacts that we have faced in terms of numbers and also economic impact, comparing two periods of 20 years. What we can see in terms of the number of disasters, and just please note that these disasters are basically considering the disaster that we call intensive disasters. It is the large-scale disaster, not having into account the small-scale disasters or more recurrent that are usually lost in the registry. But basically, we have seen an increase in the number of disasters compared to the last 20 years, comparing the periods of 20 years. And we can see in the last point how much it means in terms of economic losses. And we see that basically globally, the economic losses have nearly duplicated in terms of impact. What it means for the region of the Americas and the Caribbean, this is of a particular interest as a context of what we are trying to assess in the systemic risk, is that the economic losses have been concentrated, as particularly those losses that are related to climate origin, have been absorbed by the Americas and the Caribbean. Nearly 53% of the economic losses have been absorbed in the region. What it means is basically that if you consider the extension and the total population of the Americas, of the Caribbean, compared to other regions, for example, of Asia or Asia Pacific, where the Americas has nearly 10 times less population than this other region, but the region is anyway absorbing a large percentage, I think, unproportionately to the size to other regions in the world. And where these losses are concentrated, if you take a look of the 10 top countries in terms of economic losses compared to the GDP, nine out of the 10 top countries in the last 20 years are in the Caribbean or the Caribbean rim, with exception of one only, which is in Samoa, but the rest are basically concentrated here. So this is basically the context in which we have to operate. This is the context we need to observe closely to see what we are doing and what we can do better to reduce the economic losses of disasters. If we have an aspiration of achieving sustainable development towards 2030, it is very unlikely that we are going to do that if we do not protect the economic assets in which this development is going to be based. And then this scenario changes. I mean, if you add to that climate change, and not considering the COVID-19 impacts that are going to be extreme in terms of the impact of the region, it is expected, for example, to this study that we prepared with ECLAC, estimated that the Caribbean is going to have a recession of nearly -6% in 2021. The rest of the region is around 9–10% of economic recession. But the Caribbean is given the linkages it has into different sectors, it's expected that this is going to be the impact. So climate change, basically what it does is exacerbate the risk scenarios, exacerbate the potential losses that we can suffer in a particular area. If you take a look, for example, to this graph, we have made this exercise to compare what would be the annual average losses with and without climate change. You see that in the case, for example, of Bahamas, how this increased, or in the case of Puerto Rico, how when you introduce climate change, the climate change aspect, then you change your 4 billion estimated annual losses to nearly 5 billion. So this has obviously an impact, and we need to take a look and fit how these systems and how the early warning systems are going to address this consideration and use this type of language to reach to the decision makers, in this case, not only the national institutions in charge of emergency management, but also the national institutions that are in charge of allocating resources and coordinate the action of different sectors to take action. Because the consequences are very real, and we have the elements and instruments to measure that impact in terms of economic losses for a specific country. The approach of the systemic risk is anchored in the idea that what we are seeing now and expecting nowadays, which is that surprise is the new normal. What we consider that was unusual in terms of different events happening at the same time, and this is a graph that we prepared in 2019 before the COVID impact the whole world. It is that all the events are interconnected. All the sectors have to do and have a role in addressing these risks. And what we have been doing in preparing ourselves in understanding the risk is trying to compartmentalize these ideas of risk in order to understand better, but not necessarily this is helping us to actually understand the complexity that we are seeing today. This is an example of the cascade effects of risk that was prepared in 2019. It is basically saying that what we're seeing usually is the tipping point of the events, the tipping points of the risks. But the risks obviously have connections among different sectors. And one specific area, like let's say in a case of global warming, it can lead, for example, to market volatility, to food insecurity, and then go into feedback loops, into social unrest, instability, and then go on and go on and go on. It is very unlikely that we can address a specific risk and solve the problem if we do not take a look that is also interconnected, or at least at the same level of complexity of the reality that we are facing today. So the GAN 2019, when analyzing this context, called for urgent actions. First, to understand the multidimensional nature of risk, addressing risk from a systemic perspective, increase the individual and collective responsibility in the process of creating and reducing risks, and the need for interdisciplinary research approaches involving non-traditional partners and enabling innovative and collective action. And this is basically what we see sometimes when we approach some actions, let's say in a particular country in the Caribbean or the rest of America, is the isolation of the actions of disaster risk into one specific sector, unit, or ministry, without taking into account that these effects to be actually relevant to address those risks need to be interconnected. This is an approach, this is an analysis that we did for the Caribbean based on this systemic risk. We try to analyze all the aspects of different connectors that existed in the Caribbean, trying to assess what would be the entry point for assessing the systemic risk. The Caribbean, for example, if you analyze the context, we have dependence of foreign tourism, we have coastal populations in urban centers, most of them concentrated in coastal areas. We have poor infrastructure or low agricultural production. This is like this describing a context, but you have multiple stressors too. You have inter-regional displacement, and you have seen that recently through the impact of the migration in Venezuela. Some of this part of this migration has also landed in the Caribbean. We have low remittances of of low remittance flows in some of the Caribbean areas. We have limitations of access to clean water. We have food insecurity, and then we have the adding to leading to these multiple systemic failures, like the pandemics and unavailability of services, goods for basic needs, inaccessibility of disaster sheltering, overwhelmed disaster response capacities, reduction of financial capacities to meet basic needs, continuous disruption of basic services. This is the connection. This is a loop that we are seeing in the Caribbean. It is very unlikely that we are going to address these loops just looking into one single sector or just focusing into one single institution like the national emergency offices to solve these complex loops of impacts. So the basic conclusions that we are putting forward, and this is not finished work, is that basically the nature of systemic risk, which is complex, requires this transcending this compartmentalized and sectorized department approaches to disaster risk. And the compounded vulnerabilities affect most at-risk groups, and we have to take it. We have seen this in the compounded effects of disasters, hurricane season, COVID-19, all affecting the same population and difficulty not only the response but also how we address the situation of particular vulnerable population. And institutional coordination and collaboration with civil society is becoming a must. The policy recommendations coming from this analysis enhance multi-hazard disaster preparedness efforts, and we see here, for example, the connection on the information from the specialized agencies producing this information, climate information, does not necessarily reach the communities, does not necessarily reach larger populations, and then there is a need, this intervention of civil society or connection with civil society to transform this information into action or policy actions. We have to also look proactively to reduce vulnerability from other hazards, not only look into one. We have also seen that there are multiple effects, connections between different sectors, and whatever response we prepare here needs to be a multi-sectoral effort. Not only multi-sectoral, talking about different ministries, but also different levels of the governments, national governments and local levels governments. And also the need to protect older people and other vulnerable groups, and the need to prioritize integrated disaster risk management. These are some of the ideas that are coming forward from this analysis. We are going to launch this report in incoming weeks, and basically the idea is that we need to move from disaster management, the idea of how we better respond, how we better organize ourselves to address response, to link this process of disaster risk reduction to the agenda of sustainable development, actually how we can manage disaster risks, how we can learn to live with this uncertainty and complexity that we are seeing today, and how we can better rethink our governance mechanisms to be able to be at the same capacity to the complexity that they are facing today. So this is what we wanted to share with you. And again, our apologies for this late connection. Thank you.
Yes, I could unmute this time. Thank you, Raul. Thank you so much for this this presentation, which in a way is kind of already closing some form of loop compared to the previous presentation that were made. And so thank you very much for that. Also for this perspective that you're providing us, which I'm totally supportive of. In fact, the specialized agencies and for those that we're involved in with the weather and climate business, we have the form of privilege to have some forecasting capabilities for weather timescale, but also for climate prediction, and of course making the best out of the science that is involved in that is part of the challenge that we are happy to face with partners, as you indicated, in all the presentations, we've had a similar remarks on how crucial it is to have the proper linkages, either at operational and real-time scales, but also on the policy making, on the institutional arrangements in the countries. So thank you very much for this insightful presentation. We are now done with the presentation, so we still have some time for the questions, and hopefully we'll have a nice discussion now. I try to monitor on the chat. I saw some traffic there. The first question was a rather technical one on storm surge prediction. This was a question for John, from John also. Thank you for the question. John Tibbets, if you could just expand a little bit on the early reply you provided in the chat, because as you all understood from the presentations, this tropical cyclone business is already in itself a kind of multi-hazard challenge that we have to face. The classification of tropical cyclones is mainly based on wind speed, yet the actual damages are a result of the combination of different types of hazards: wind speed, rainfall that results in landslides, flooding, and coastal inundation due to storm surge and waves and things. So this is already a complicated approach where uncertainty is sometimes a bit challenging to handle. So John, please.
Okay, thank you very much. Can you hear me?
Yeah, perfectly.
Okay, no problem. Back 6 years ago, 8 years ago, we brought some professional storm surge modelers down to Cayman, and they used the Tahoe model, and we had two components of our storm surge program at that time. One part of it basically was the production of a storm surge atlas. And basically what a storm surge atlas is it's a map of various tracks of storms going across your area at various intensities, and you will see what the storm surge is across your area. So it is an excellent first guess at whatever storm surge is going to impact you. However, it is not perfect. I give you the example of Cayman Brac, which is one of our smaller islands. We have two storms went across Cayman Brac, basically the same intensity, same forward speed. Okay, one generated a 20-foot storm surge, the other one generated no storm surge. Okay, and that's a limitation of a storm surge atlas. That's why you need to have a storm surge project itself. And for you to get a storm surge project, you actually need high quality bathymetry data, seabed data. So you need to get what we call LiDAR bathymetry data, which is on the expensive side. But if you can get it, it can help you with storm surge. It can help you with wave tracking. It can help you with tsunami. It can help you with a lot of things. And Cayman is working towards getting that, and then working with the National Hurricane Center to get a storm surge project in the Cayman Islands.
Okay, thank you for this explanation. From this explanation, I understand that you are already equipped with the sensors that allow you to assess the storm surge when they occur. So you can compare it to the atlas and the prediction probably.
We do have some sensors on the island, but they don't belong to the National Weather Service. They actually belongs to the local lands and survey company and stuff like that. So they will give us back whatever feedback that gets from their information. The other component about this is that you need to realize that, of course, that the Cayman Islands are very low lying. The highest point is on Grand Cayman, the largest island is about 40 or 50 feet above sea level. Okay, so storm surge is a major problem.
Yeah, sure, I'm trying to understand. And obviously this is another illustration of the need for cooperation between various agencies, entities to share data and bring things together. Okay, excellent. Let me scroll down the chat. We have comments and discussions started on these relationships that need to be developed. Let me check on the actual questions. Yeah, a question. From Musa and discussion with John, maybe both of you could further develop a little bit on the constraints that you experiment in developing this impact approach that we're promoting from a WMO perspective, of course, as it is a significant improvement beyond the mobilization of science and technology for computing purposes and everything to make the best use of the information that is available, so it is understood, it is actionable, but it is not so easy to implement, hence the need for development projects and sustained efforts in that area.
Well, I guess from my input on this particular section, I see the major constraints for this basically is in two forms. Proper tools, okay? You've got a hurricane coming through. You need one set of specific tools to deal with the storm surge, another one to deal with the wind, another to deal with the rainfall, all right? So you've got to have a suite of tools that to use. Okay, and not all organizations have all of these tools. Second part of it is you need a significant amount of staff because you need one person can't do the entire job. You need a specialist that can deal with the storm surge, a specialist that can deal with the flooding aspect of it and the wind aspect. So staffing is an issue. And as I said in the presentation earlier, we're looking at this right now from a DRR point of view. But when you're dealing with a National Weather Service, the National Weather Service has other customers. My largest customer is actually aviation. Okay, and a lot of the small islands, their customers are aviation, and aviation takes up a large part of the job. And so you need to have a significant staffing complement to be able to, you're dealing with aviation, and then you're also going to have to deal with this impacts-based type forecasting as well. So staffing is an issue. Sometimes you can get it through the DRR system in terms of when you're working in collaboration with them. They will drive your government to hire more staff for you. So that we can help them. Okay.
All right. Thank you very much for these additional details and consideration. And yes, manpower qualification skills is part of the challenge, obviously, and this is where we are trying to be as supportive as possible. In a lot of different threads of activities. There was a question then Was it from Murray Dale on the key steps in achieving collaborations? Am I correct there? Yes, and there were some traffic also on these kind of considerations from. So any of the presenters is welcome to provide his views on that. It's also very much aligned with what Raul mentioned, that this comprehensive and multi-sectoral approach is far much more developed than what it is at the moment. Any of you would like to comment on this? I see Rodney appearing on my screen.
Yes, thanks. Thanks, Cyril. I think there is a convergence of the comments in the speakers in terms of what is needed. Of course, we need to make more efforts in the technical aspects, in the operational aspects, because they are key, they are critical. But also there is a coincidence in terms of this more increased and improved interaction with the DRR communities. And indeed, it's not just with DRR communities, with intersectoral communities. The systemic risk approach and concept that Raul explained is closely related with the multi-hazard early warning system operations. But we need to work with the institutions, and we need to work with the persons, and we need to work to enhance the governance. And it's something that we need to really conduct and facilitate with a UN interagency work that we are trying to promote here in the region, and Raul can expand on that, because it's the only way that we can facilitate our members to really work together. This is a key experience from the last hurricane season, especially in Central America, and it's promising also because everybody, all the actors, all the stakeholders identify this need. So we need to work on that direction. Thank you.
Thank you, Rodney. I also saw Musa and Alan successively appear on my screen. So probably Musa is willing to provide a comment on this. Musa?
Thank you. So my comment is related to the how we work with water resources. You know, the responsibility for flood warnings is not for Met Service, it's for water authorities. And they have some stations for rainfall data collection. And we agreed, we started years ago to share rainfall data. We collect from our synodical stations, they collect from their hydrometric stations, and they send to us, and we send our data to them. So 5 years ago was a need to increase the number of parameters to be shared. And we agreed to sign a memorandum of understanding. But before it was signed what we call a ministerial diploma, the Minister of Transport and Communication and the Minister of Public and Housing, because we're in the different ministries. So we produced the document, it was a sign. But what we do basically is during a year, so we provide daily rainfall forecast. During rainfall season, we provide not only rainfall data, but we provide our forecast, a 5 days forecast. So they use it to monitor the river bases. As the same situation happened when there is tropical cyclone. As you know, we are connected with the specialized Tropical Cyclone Center, La Reunion, and we receive the advisory bulletins. And from there, we make our analysis on the track of a tropical cyclone. But what most important for them is the amount of rainfall and in which area. For example, for tropical cyclone IDAI, we know that it affected the Buzi and the Pungwe rivers. Meteorological service were providing the rainfall data in terms of forecast, quantitative rainfall forecast for 4-5 days. And they use normally to issue their bulletins. They use hydrological bulletins. We use meteorological bulletins. And under the technical council for disaster management, we have a room there where we work together. In case of emergency, we work together 24 hours. And it means that the exchange of information is so very high during the extreme weather event. So that's the way we work with the water authorities in this country. For example, WMO established a severe weather demonstration project. It's based in South Africa. It's internet-based. And that tool, weather service as, for example, password. With that memorandum of understanding, we shared the password, and they can access directly the meteorological product for their hydrological monitoring. That's the way we work with water resource management. Thank you.
Thank you, Musa. Thank you very much. And an illustration of where people can actually meet and work together is always good to take. Alan would like to comment also, I guess.
Okay, thank you, Cyril, sorry. Yes, on the case of collaboration, in terms, I will start off with the seasonal forecasting. In terms of our seasonal forecasting, just climate seasonal forecasting, we are working with directly specific with 5 sectors. It's the agriculture sectors, the water sectors, the fishery sectors, and then we have tourism as well, and the infrastructure sectors. But these are early warnings through the climate early warning system, which gives the 1 month to 3 months outlook for them to plan. In terms of, and we have, we share data, using data, we share data under an MOU, just a local MOU between sectors and the Met Service. And in terms of early warning to do with severe weather forecasting, that's a challenge for us. Flood forecasting, there's no flood forecasting system in front of the moment. So what we do, we just embedded that in our public weather. So no specific flood forecasting system for us. And that will be, I think we're still under discussion with the regional organization, the SPREP and the PMC, Pacific Meteorological Council. So we are having discussion with that, not only Vanuatu, but other Pacific Island countries as well. So I think Fiji has already had its flood forecasting system in place, but for other Pacific countries, they still lag behind in that. So that's another thing that we need to work to achieve that one. And I don't think the water sector will have the capacity and capability to run the flood forecasting. So it falls back to the Met Service to do that one. The Met Service has the networks of rainfalls around the islands that we usually collect rainfalls, and through the synoptic station and through the automatic rain gauges. So that's other things that we'll have to work on that one as well. And the other thing is for the disaster management, we are working closely with them, but not to that level that it needs to collect data. What the data collected through the disaster management are only for humanitarian information, but not for the scientific information to lead to impact-based forecast that we are talking about. So that's another thing that we are looking into, and I believe that there's a program, a Weather Ready Pacific program, that we can tap into that one to help us with the impact-based forecasting. Yes, so I think that's what we have at the moment. Thank you.
Well, thank you very much. And I would like to link this with the previous discussion on staffing and having enough skilled resources. There is a question in the chat from Jerry Languasa, who is very much aware of how WMO works, of course. Thank you for attending the session, Jerry. And his question is about outsourcing resources. As you all know, for the wider audience, WMO has established supportive frameworks in various areas. The collaboration started with sharing observation, because this is the fuel of our work on a daily basis, but also for forecasting and data sharing. The concept is that advanced services make the result of their work in terms of data available to members with less capacities. So this is about data access and interpretation where skills are needed. And there are different networks of specialized centers, and the one for tropical cyclones is a typical example where not only data is made available, but also expertise and guidance is shared by the regional specialized centers to their neighboring countries. And so Jerry's question is, we can probably link to that and to the remarks by John on the need to have more resources on an ad hoc basis when something is developing. This is a feature that can be implemented by large services where you have enough staff. You can get organized to have on-call additional people coming in to support a specific situation, while in smaller services, this can be simply impossible because the resources are so limited. And so Jerry's question is about outsourcing skills and competencies from other agencies, including private sector, as a possibility to complement the supportive framework that already exists, and to close this this gap here with a comment that if smaller neighboring countries like in the Caribbean through a regional organization like CMO could coordinate that could possibly be a way to better handle these times of crisis when tropical cyclones are rolling through the basin. So happy to hear your comments on that question and suggestion at the same time. And it can be for John, of course, but also the other presenters are also welcome to comment on this, of course.
Well, first of all, we work extremely close with CMO. In fact, the head of CMO is actually my WMO representative at Congress. Okay, and so we're on kind of like on a first name basis, so to speak. However, the problem is CMO is really not an operational center. It's an organization that it supports a lot of things, including the training center that's in Barbados and what have you. But CMO is their mandate and what they can do and what have you doesn't lend itself necessarily to issuing, let's say, warnings for a particular country and what have you. That being said, I'd prefer them than having it outsourced to a further country, because sometimes they don't even know where the Cayman Islands is located. All right, much less to know that the Cayman Islands is very low lying and what have you. I remember way back in 1988 when I started in this business, and we weren't responsible for our own warnings. And we had, if memory serves me right, we had Hurricane Gilbert going through, and the bulletin came out from the Hurricane Center, and it said Cayman was going to have 20 to 25 inches of rainfall, and we were going to have landslides. And my director at that point said, "We're flat. Where are we going to slide to? Cayman doesn't have landslides. It's too flat." Moreover, Cayman does, because we don't have mountains, we usually don't get extraordinary rainfall totals. So you would take a tropical wave and send it through the likes of Puerto Rico, for example, and they would have all kind of problems because the mountains in Puerto Rico would force it to rain, and they would have a lot of floods and what have you. We don't have anything to force it to rain in Cayman. We jokingly have a Mount Trashmore of about 60 feet. So we can't be talking about orographic lifting or anything of that sort. Outsourcing it, it would be nice and what have you. In the local community, we don't have meteorologists or professionally qualified people, even in the DRR field, outside of what is there already. So we don't have experts in DRR retired in the Cayman Islands, expert meteorologists retired in the Cayman Islands. We don't have a lot of that to rely on. Other countries, yes, they do. There are other countries in the Caribbean that do have these retired people that they can utilize and outsource some of the stuff to. All right, but it's difficult in the Cayman Islands in that regard.
Okay, thank you for the feedback on this. I guess the question was also possibly on mutualizing resources between neighbors, as an example, with the possible issue that you just highlighted on landslides in Cayman. Of course, but with a proper preparation, I guess this is something that could be discussed, and it is actually the baseline of what our regional centers are delivering to the neighboring countries. But at some point, they themselves may face also resource issues when multiple situations are developing here and there. Interesting consideration and question here that we can probably follow up in the times to come. Okay, and I see there were some traffic in the chat with some comments also there, so I will not go into the full thread here. So consideration that flood and water managers need to have flooding information due to tropical cyclone. Now, allow me a short comment on this. Because of this multi-hazard attributes of tropical cyclones, Raul mentioned about this report, and we all are interested in understanding what are the impacts, what are the loss and damage information, because this is the basis of the development also of impact-based forecasting. Without any knowledge of the actual impacts, be they large-scale events or smaller-scale events that can be cumulative over time for the same locations and communities. There is little hope to be able to co-design impact-based systems that will really trigger early action and efficient actions. So in this regard, when we deal with these types of information and reports, there is an issue of attribution, not in the sense of attribution to climate change, which is a totally different topic, but when you explain that when you report that a number X of houses were destroyed because of tropical cyclone, of a tropical cyclone event, an additional level of information would be interesting to know and to record. Were these houses destroyed by the wind? Were these houses destroyed by a flood, by landslides? So the more accurate the information is, the more developments we could consider in improving the warning information, but also the response and the anticipation of these events. And in that regard, I would like to remind you that in this year 2020, the UNDRR and the International Science Council released a revision of the Sender Hazard list with updated definitions and which is a new reference of its kind here. And from a WMO perspective, we're developing a cataloging approach for hazardous events that we are hoping to make available in the coming years to serve as a link between loss and damage and technical information on the hydromet hazards. Okay, we only have a few minutes left. Let me check if we have questions, additional questions. There are a number of posts in the chat.
Well, I think that UNDRR might want to come in.
Oh, yeah, Raul is there. Raul, you're welcome.
No, not particularly, Cyril. Thank you. No.
Thank you, Erika. Okay, where are we with the chat? Yeah, regional approach to maximize available resources. We discussed that. Right. Okay, so we are almost there. I would like to thank you all for your contributions, the questions and the comments that were received as well. We'll keep track of this, of course, and probably we'll consider some follow-up in the times to come in the next weeks, probably. I would just like to conclude with some persistent messages that we can take away from this discussion. It is about collaboration. It is about integration. Or maybe I hope you don't have too much background noise. There are some. Okay, let me count. So collaboration, integration, putting resources, common resources in place where needed. This is what WMO is also very keen on, but also some strategic recommendations or challenges that were highlighted on how we can demonstrate efficiency of what we are doing here. This came from the presentations, and how credible we are in the messages that we are delivering, so people can really anticipate the situations and be as safe as possible. So efficiency, sustainability of what we're doing, this comes also with the assessment of socioeconomic benefits, which builds also on the loss and damage recording. And this is a huge component that can attract and demonstrate the need for further investments in the different areas that contribute to a proper risk management in these areas. Just allow me to end with a short comment on how particular this year 2020 was, because also of the pandemic. As you all know, it has increased risk throughout all of our societies, but also in the hydrometeorological and early warning system value chain, because even observation, hazard monitoring was impacted because of the pandemic, of the restrictions of people to move based on government measures, and also on staff availability and to perform their work as usual, to analyze situations, provide warnings, disseminate them to support early action decision-making. So we at WMO made a survey to kind of assess how our member med services, hydromed services also were impacted. And it appeared that less than 60% of the respondents indicated that because they were considered as critical entities within their government structures, they could benefit from adapted measures to facilitate the continuity of their work. And so for some of them, it had very practical consequences. And we have to highlight how dedicated people were in trying to provide these services, because tropical cyclones in particular, but other hazards, didn't stop for the COVID pandemic. And so we had to be there and to deliver with even longer lead times when possible, and adapted advice because of the pandemic additional layer of risk, evacuation, sheltering, and these crisis scenarios had to be adapted to the situation. So this was a kind of difficult situation for a lot of colleagues here. And it really highlighted and underlined how critical the services that are delivered here are key in allowing early action for people to stay safe. And by the way, you probably have noticed that today, a cyclonic storm, Burevi, is heading towards Sri Lanka, close to Trincomalee. So let us hope that people are prepared there and can be and suffer as less as possible from this event. And with this, I would like to thank all of you for attending, participating, contributing to this session, and in a way or another, we'll be connected again soon, I guess. Thank you very much.
Thank you. Bye-bye.